Alright, so here we have this question, validate binary search tree. So herein what we have to do is we have to tell if the given example is a binary search tree or not. So what is a binary search tree? Uh, it is a tree in which we follow a particular order, and that is that on the left hand side we put the smaller elements and on the right hand side we put the greater elements. So is this a binary search tree? Yes, because we have a root node and then we have one that is smaller than the root node, and then we have 3 that is greater than the root node. Here it's not, because 5 is small, 1 is smaller than 5, so it's on the left hand side. 4 is smaller than 5, but it's on the right hand side. Can't be possible. Every smaller element will be on the left hand side. So yeah, exactly. So how do we do that? What we can do is we can say that, if a node is null, if a particular node is null, then we know that it's true. Either you'll have 2 nodes, or yeah, if a node is null, let's check that. Cool. So if a node is, we'll have a helper function, and then we'll say that, so the basic thinking is that for every, let's write the base case first, that if a node is null, it's true. Because if a node is null, like for example, if I encounter a node that's null, if I go on the left or the right hand side of one, if I encounter null, it's not a false statement. It's like, it's true, Yeah. So I'll just take in this tree node root. My bad. Yeah. So now what's the understanding? Smaller ones on the left hand side, greater ones on the right hand side. Yeah. So what's happening is that for every element that is coming on the left hand side, the thing is that the high is fixed. It can't be greater than the node value, right? So herein 1 cannot be greater than 2. It can't be 3, because then it's going to lie on the right hand side. So whatever element is going to come on the left hand side, we'll have to make sure that its high is fixed. It can go lower. Low can be anything, but its high cannot be more than 2. Yeah. Cool. And the moment we're moving on the right hand side, we know that on the right hand side, its high can be like, it's gonna be like, like for example, if you're going on the right hand side of 2, it can be anything. The high can be anything, but the low has to remain fixed. What's that? That it cannot be lower than 2, right? So the high is fixed on the, when we are traversing on the left hand side, when we are moving on the left hand side, the high is fixed. That is node dot value. This node dot value high is fixed. When we are moving on the right hand side, the what's fixed? Yeah, the lower value is fixed. It cannot be lower than the node dot value, than 2. So if it's less than 2, then it's gonna lie on the left hand side. So yeah. So we can have a high. Yeah, we can have low, and then we can say if node dot value equals null. Return true. That's fine. If it's null, it's fine. But the value cannot be null, by the way. My bad. If node equals null, if we encounter a null node, then we have to return true. Yeah? Cool. What else? What else? For this node 2 we'll check. Yeah? For this node 2 we'll check. If node dot left dot val greater than if it's greater than what was fixed, high was fixed, high, yeah, and if before that, if node dot left is not null, and if node dot left dot val greater than high, return false. How is that possible? It's not. And let's have this thing. Yeah. If we go towards the right, if node dot right is not null and node dot right dot val is less than equals low, yeah, I'll return false. So this is what's gonna happen for every particular node. But the thing is that here we're gonna have recursion. So recursion is gonna go at the bottom first and then gonna come up. So the thing is, recursion will be for starting with like this. I'll have node 2 as the input, like, you know, I'll put the node right here. Yeah, I'll put the node right here. Then I'll say that, alright, for this node, do check it. For 2, it's gonna be like, you know, if it's left dot value, if node dot left is not null, it's not null. And is node dot left dot value greater than high? No, it's not. Alright, understood. So the thing is that I'll have to, you know, do something like, how do I know what the high is? How do I know what the low is? Because I'm like, node dot right is null. No, it's not. Then node dot right dot val, is it less than the low? So the thing is that how do I identify what's the high and what's the low? Yeah. How do I identify what's the high and what's the low? That is the question. Yeah. Initially, it would be null. Yeah. Initially, what's the high and what's the low? It's going to be null. Yeah. Because, for example, what's the, you know, high for 1? Right? Like, what's because we can't just say this is going to be high for 1. No. The reason for that is that I can't say that every child's parent is their high, right? Because that thing won't work here, because every child's parent can be their high. So with that thing, it's like, for example, for 4 was lying on the right hand side, right? 4 was lying on the right hand side. So the thing is, for 4, the high was anything it wants to be, because anything greater than 5 can lie here, but it cannot be less than the low, right? 4 cannot be less than the 5. It cannot be less than 5. If it's gonna be less than 5, it's gonna lie on the left hand side. So, yeah, I mean, the thing is, if I'm having all these cases put in, what will I qualify as the high and the low? If I say for 5, for example, if I say for 5, null is high and null is low, yeah, if I say that, it's gonna say is node dot left, is node dot left null. It's not. Is node dot left dot value greater than high? Like the for example, the confusion is like I'm having int here, so I cannot be like null because it's int type. And if I'm gonna have null, I can't just compare value because what's null dot value? It's nothing. For example, if it's null, 5 dot left, node dot left dot value, is it greater than high? High was null. I mean, that's the confusing part, I would say. Like, what can be the high that I said? What can be the low that I said? Because the thing is, I cannot just call it to be the parent, because if the tree is gonna go into a depth, the thing is that 3 is lying, like for example, this case would have given false, but the issue is that for 3, this tree is valid, this subtree is valid. That is the issue that we'll be encountering. Although 3 is less than 5, so no way it can lie right here. That is the point. What if this was 9? Let's assume this was 9 and this was 10. It would have been fine. But still, for 9, 3 is gonna lie here. It was not fine. Because then everything would have been alright. The issue would have been, alright, for 5, less than 5 is on the left, 9 is right here, greater than 5, 10 is right here, greater than 9, fine. The issue would have been this 3. 3 is all the less than 9, which is fine. Which would have been fine if you just take parent into consideration. We cannot take parent into the consideration. We'll have to maintain from the root itself. Yeah? We'll have to do that from the root itself. So how do we figure that out? For every recursive call, so basically what we are doing at the moment is pre-order. Pre-order is like we're taking node into consideration, then we are taking left into consideration, and then we are taking right into consideration. So we are doing pre-order. Yeah. So I'm saying node dot left, node dot right. Cool. And then I'm getting the values of it, and then I'm just comparing it. The thing is that my cases are fine. That if the left part is greater than the high, you have to return that. or something. The thing is, I also cannot say root to be the ultimate factor of consideration. Why? What if the root is 5? What if here it was 10? What if here it was 9, which is completely fine? Because 9 is still on the right hand side. So I cannot say that alright, 9 is greater than 5. Yeah? So return false. I cannot do that. Yeah? Yeah, I cannot do that. So what's the ultimate point of consideration? How do I pass that down? Yeah? How do I pass that down? That is the question. What if I keep updating? What if here I say that return helper, wherein I say put the root, and then the high can be root dot value, low can be root dot value. What if I do that? Yeah, I say this, and then what I do is that I say that, yeah, and then I say that alright, I did it for this particular node. Now I'll have to do it for the left boolean. I'll have to do it for the left, and then after doing it for the left, I'll do it for the right as well. Yeah, I'll move to the left part and do the same thing. I'll do the right part and do the same thing. So this is like left subtree, right subtree. So I'll say that in left, what I'll pass is the helper, and then I'll say I pass node dot left. For high and everything, I'll say node dot left dot val. But how can that be a low? But okay, it can be. Let's not get messed up with the words. Yeah, and then both have to be true. So return left and right. Let's see. Null. How do I take values then? How do I take values then? That is the thing. Because here it's gonna get null. No dot left dot value. How do I compare then? How do I have the high and the low then? Is it gonna help? No. What can be done? What can be done actually? Because I cannot take the value, because obviously let's see. Alright, so I just did what I just didn't want to do. I just said it myself that uh, I cannot do it for the direct parent, and that's what I did. I did it for the direct parent, which won't work obviously. So, what can be done? I'll have to take the answers into consideration, of course. I have to take this into the consideration that every element on the right has to be greater than this, so it cannot be like this. How do I take that ancestor into consideration? Can I just say for root? Like, yeah, I just say root. But will it know what root is? It won't. I don't think so it would know what root is. Yeah, what's root? Yep. Alright. What did I say initially? What did I say initially? Let's talk about that. I said that for left, the high is fixed. Yeah? High is not changing. Nothing can be greater than 5. So high is fixed. Yeah? So I'm just saying that node dot left, and then my high is gonna get fixed. What is my high gonna be? It's gonna remain unchanged. How do I take that into consideration? Like my high is gonna remain unchanged, so what do I put right here? My low is gonna change for left. My low can be anything. Less than 5, it can be anything. So how do I take that into like code thing? Like how do I say that my 5 on my left, my high is gonna remain unchanged, and yeah. How do I say that? Let's see what code have they provided. Yeah, so they have said low is gonna remain like the way it was. Okay. Okay. Yeah. So the thing is, for left, like low can be anything. High will stay fixed. Low can be like, you know, high is gonna stay fixed. That is the thing. But my low can be like anything, so but thing is that when I say for 5, my now I'm moving left, so I'm saying node dot left. I'm at 1. I'm at 1. I'm saying that yeah, high has to remain fixed, and then I'm saying that it can't be greater than 5. But then I'm saying that the low has to be no dot value, right? Cool. Why do I say that? Because the thing is that at any cost it can't exceed 5, whatever is going to be on the left of 1, if there's going to be something. But the thing is that whatever is going to be like on the left hand side of 5 for 1, if you talk about, so its high has to stay fixed. Its low can be anything. I mean, yeah. So it can't be greater than that low if it's on the right hand side. That is something. But high is gonna get fixed. Like for example, if it wouldn't have been 1, if it would have been 4, for example, right? So like suppose this thing is gonna fit well right here, let's assume. So I can say alright, now for node 4 we'll talk about. On the left of, so for node 4, my high is fixed, it can't be greater than 4. My low can be anything, na? My low can be anything. 3, 2, 1, it can be anything. But so that's why I said my low value is no dot value. If my low exceeds no dot value, then it's an issue. Here I'm gonna say no dot right, and then I'm gonna say that now my high cannot exceed the node value, node dot value, but my low can be like anything. You know, my low, not my low cannot be anything. My low is now gonna be like, for example, if I'm on the right hand side, so anything greater than 5 can be on the right hand side. But initially, what was my low? Initially, my whatever my low is, it cannot go below that. And wait a second, it's getting confusing. When I'm traversing on the right hand side of 5, yeah, when I'm traversing on the right hand side of 5, I'm saying that whatever is the value, yeah, that is my highest if I'm putting it right here. So no, that is where I messed up. No, that is where I messed up. I cannot say that. Wait a second. We'll have to do it again. Why do I do that? When I'm gonna move towards the worst test cases they have given, how do I even figure out from it? Seriously, it's not having anything beyond it. But let's okay. For node 5, there's no dot left. Null is no dot left value greater than high. Here my high will have to be fixed. I cannot exceed my high, that is no dot value. For like right, is my no dot right less than my low? Because here my low is gonna get fixed. Here my low is gonna be no dot value. Cool. Now let's talk about that. So for my left, my no dot value is my high. For my right, my no dot value is my low. Sorted. So what did I just have? Why is it flickering? Yep, so for my left, my no dot value is my high. It cannot go beyond that. Yeah, my no dot value is my high. It cannot go beyond that. Yeah, my low is my low. We'll talk about that. Here my high is my high, and my low is no dot value. It cannot go lower than that. Yeah, what I'm gonna set my highs as, initially for root, my why can it not be this? My low is root dot value, that for my function. My high is root dot value. I cannot go more than my high root dot value. True. Yeah. And then my low is this. So no dot right. My value cannot be lower than this. What's the issue? Yeah, accepted. Oops. What's the issue? output is coming out to be true. Well, expected to be false. Why so? Because 3 is right here. Alright, let's try run for it. Shall we? Let's have a try run for it. I'm saying that I have an helper. I like pass root and dot value in it. Cool. Now I say that it's not null. No, it's not null. That's a non dot left value is greater than high. No, it's less than high. It's fine. It's not right value. It's no dot right value 6 less than low. No, it's not. It's greater than low. So it's fine. I move towards the left. No dot left. I pass this as low and this has high. This has high. And yeah, cool. And low as like 5. Anything below 5 can be pasted. But no worries. It's null. I mean, 4 is not null. I mean, its left is null. So, yeah. This thing is done for 5. This side is done. Yeah. What if I do this? No. Yeah, it's fine. So no dot left is null. Yeah. This thing won't get executed. No dot right is also null. So again, so my left is sorted, I guess. It didn't return, so then like it never returned false, so cool, I guess. I passed no dot left. I have a 4. This left is null, this right is null. So yeah, I go towards the right then. Here I see I pass 6. I pass 6. Then I see is like 6. 6 is left. Is it like greater than the high? Or was high was passed as 5? For 60 now high remains 5. Yeah, high remains 5. So it's like, is it greater than high? No, it's not, it's fine. Low is for 6. So is it like the right one, like less than low? Oh, I see. But wait, it cannot be less than 6, understood. But 3, like for example, like my high for left, my high for the right the right one, I passed this for this side, I passed high as this root dot value, that's fine. Then I say now dot left value, is it greater than high? Is 3 greater than high? Oh, it's not. The thing is, I can't wrap my head around the issue. But why is it happening? I know 3 has to be there. How do I figure that out? Because I am saying that no dot left dot value greater than high, because it's like, if it is, if whatever on the left hand side is greater than the high that is set for it, yeah, that is, but that is the point. It's on the right hand side. It's on the right hand side. The 3 is on the right hand side. So high for it is fixed. That is, from my code, it's root dot value. High is fixed. It's 5. High is fixed, that's 5. But high can be anything, nah. That is the thing that's bugging me. High can be anything. But then again, it's on the left hand side. Like on the right hand side of 5, as the root node, anything can lie. But for 6, when we talk about the left hand side, still that's on the right hand side of 5, but on the left hand side of 6. So node dot left, if it's greater than high, yeah, understood. I would just, I know this would give error. Just tell me why. So there they are saying that the high can be anything and the low can be anything, and my order is wrong. They're saying that my order is wrong. My ranges are wrong basically, because they're wrong, and thing is that I'm limiting my high, I'm flipping the range to something like for my left. I'm saying that my high can be null dot value and my low can be whatever's set initially. And here it's like I'm saying that my low and high will be between, like my high will be 5 and my low will be 5, like my node. All right, let's understand it again. So the thing is that uh, I need to make sure that I can go left, I can go right. My node value, yeah, for left, when I'm moving in the left direction, I cannot have something that is greater than my node value. Yeah. So when I'm moving in the left, my high will be. Why is this wrong? Why is this wrong? I'm saying moving in left, my high should be parents value, not above that. When I say this is the low, I'm saying that uh, 20 is the low for this example. So when I'm saying 20 is the low and my high is like no dot value, it cannot exceed uh, 15. For my right, yeah, for my right I'm saying my no dot value is the low. So yeah, it cannot be lesser than that. So it has to be greater than that. And my high is my, so it can be like whatever it can be. Higher than that. It's higher than 20. Okay, so this low and high are the issue that I'm passing initially. So that this thing is like correct for first iteration only. This is my high, this is my low. So it's like no dot left greater than high than this. I understand that. It cannot be the same. So my high can be like anything. Like, it's like when I'm traversing in my left, my my high is gonna remain the same and shouldn't be lower than something. So but the question is, when I put that as like, what they are saying, max and min, then what if on the right side of 2 it's 5? It's gonna be greater than high. It's not gonna be greater than high, that's what I'm saying. If I put high and low as max and min, then 5 can be on left of 2 and still low. It goes left and helper like node 5 low is, and my high will be no dot value. I'll check. So when 2 will be my no dot value, so but that is the issue. Oh Lord, what am I doing? I'm saying that's sad. Here I'm passing route and then for route I'm checking it's left and right, and then I say for routes left and right I check it for left and right, and then I pass this, I check it for them. When I'm checking these, never. Wait a second. Ah, oh, that's so sad. That is the saddest thing I've seen myself doing. Ooh, okay. Here it is not supposed to be left. Here it's not supposed to be right. Yeah. It's like I'm never checking into the particular range for this node and this node. I'm just checking for its left and I'm checking for its left. So the thing is that it was kind of broken. So I'm saying that can this lie in any range? Yeah, it can lie from minus infinity to infinity, like yeah. And for this, it's like alright, you're on the left hand side. So anything you see, like you're on the left hand side, so it's like whatever is gonna be on the left of 2. So for that particular node, it's like for that particular node now I have to check is that node fine or not. So for that node I'll have to check. So it has to be for each and every node. I just mentioned pre-order, then I just never took that into consideration. I was doing left, right. Yeah, I wasn't considering the node. So it's like alright. So for one, what can be your maximum? Are you in that range? Your maximum can be 2. Are you in that range? Yes. The minimum can be anything. It could have been like anything. For 3, your maximum can be anything. The minimum has to be 2. Way easy question. So yeah, for my left, my high can be that, my low can be anything. Right. For my right, my high can be anything, my low has to be that particular value of the node. So like when I'm going on the left hand side of it, this thing is like the value taken. So yeah, what's the issue? Like my node dot left. Where is it? Two big issues. This thing can be changed with this, so it's not an issue for that particular test case. This is the issue, I guess. I mean, this can be removed then. Like this check is not needed. Same for this. This check is not needed. Well, I guess anything else is not gonna be an issue. Yeah. Because I was like doing no dot left, so that was null. So this would have not been. Yeah. Now if it's gonna be initial, it's gonna be due to this integer thing. Yeah. Understood. This has to be long. Long was like written like that only. Yeah. Long. Long. Let's take this yes. Long to end. Yeah. Seven four eight three. 748. Yeah. What did he say? What is... Okay, initially he took everything as null. So yeah, I guess it makes sense. He took everything as null, so it's null. Doesn't matter whatever you do. Yeah. Then everything is same, I guess. Yeah. This was, I guess, an easy question. I overcomplicated the question by my stupidity, by not comparing the nodes, but just trying to compare the children. Yeah, he took that as null, so it's like it doesn't matter, whatever you do. Cool.